All right, what up, homeboys and homegirls? It is Coach Jakes back to make your chemistry life a little bit easier. All right, in this video, we're going to talk about the ideal gas law on this gas law topics thing. So we've talked about Boyles, Charles, Gay-Lussac. We talked about Avogadro. The ideal gas law is a combination of all those other laws without regard to before and after. So in all the other ones, you had like a P1, a P2, a T1, a T2, a V1, a V2. You don't need none of that in the ideal gas law. We're simply just going to look at a gas in its present state as it is. We're not trying to change nothing. I just want to know the information about what it is right now. Okay. So the ideal gas law's formula is PV equals nRT. At this point, you should know P stands for pressure, V stands for volume, N stands for moles, T stands for temperature, and then you have this R thing. All right, R is a constant that takes into consideration STP, so that R value can change depending on the pressure, right? So if my pressure is ATM, then my R value is going to be 0.0821. If my pressure value is in kPa, then I'll use 8.3145. If it's in torr, and this also goes for millimeters of mercury, then my pressure or my R value would be 62.3636. All right. And that changes because your pressure could be at STP is 1 ATM, at your kPa pressure at STP is 101.325, and you have 760 torr at STP, and all the R values are based off of STP. So the R values that you use will be based on the pressure that you see in the problem. All right, now 3 things you need to remember when you are dealing with the ideal gas law. First thing we just talked about, match your R values to P. So make sure you're doing math in the same units of pressure. Your volume needs to always be in liters, because if you look here at every R value, we have liters. So your volume here should be in liters. If it's not, convert. And your temperature should always be in Kelvin, because here they're all in Kelvin, temperature, KK, and all right, y'all got that? So temperature is in Kelvin. All right, so let's go ahead and get to these practice problems. This is pretty simple. My blue line went away from erasing so much. Bring it back. There it is. All right, so right here it says, what is the pressure, P, of 9.78 moles, so this is going to be our N, of oxygen with a volume of 12.4 liters, there goes our V, at a temperature of 56 degrees Celsius, there goes our T. All right, then it says answer in atmosphere. That's important. All right, so we're looking for, so we have P, V, N, R, T equals. All right, P is what we're looking for, so that's our X. V is 12.4. N is 9.78. R, we got to look up. T is 56 degrees Celsius. All right, but we know that needs to be in Kelvin, so we're going to add 273.15, and that equals 0.159. 3 and 6 is 9. 7 and 5 is 12. Carry the 1, so that's going to be 329. Equals 329. I didn't work that out. I just put in my calculator before I did my work. All right, so where do we get our R value from? We're going to look up here at our R values. Again, number 1 says match R value to P. So it says answer is going to be an ATM. So we need to get the R value for ATM, which is going to be the 0.0821. All right, then we're going to use our formula, PV equals nRT. PV equals nRT. PV, you know, I didn't go to Prairie View. I went to A&M, but my wife went to Prairie View, so there's that. All right, and then we're just going to plug in our variables and solve for X. So for P, we'll go X. For V, we go 12.4. Equals N is 9.78. R is 0.0821. 0.0821. My brain moving faster than my hand. 0.0821. And my T is the 329.15. All right, y'all can check my math on that. That might, I think that's right. Can y'all see that? Is that right? Oh, it's right on the edge, huh? All right. So then you multiply all these, divide by 12.4, and X will be equal to 31.3134 7119 sig figs would dictate 2, 3, and 3, so 2 sig figs. So we'll only keep the larger two place values. So the answer would be 21, and that's pressure in ATM, so 21 atmospheres. All right, you got that? If you need to pause, you can pause, go back, watch a couple times, doesn't matter. All right, and now we got number 2. It says a gas in a 4.7 liter bottle, so that would be our V. All right, at 273K, there goes our T, has a pressure of 1,421 torr. There goes our P. What amount of gas in moles we're looking for in will be present in the bottle. All right, so we know we got a P, a V, N, R, T. Boom, 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 and boom. All right, P equals 1,421, and that's torr, so that's important. V is 4.7 liters. N is X, that's what we're looking for. We'll come back to our R, and T is 273K. Good, it's already in Kelvin, that's great. Liters is already in liters, or volume rather, it's already in liters, that's good, because we don't want liters in Kelvin. Now we gotta go figure out our R. Remember, it says to match R value to the P. So if our P is torr, then our R value should be the R value with torr in the units. So we're going to use 62.3636. All right. And then we have PV equals nRT. We will plug in from there. So our P would be 1421. V would be 4.7 equals N. That's what we're looking for, X. Now our value in this one is going to be the 62.3636, and the T is 273. All right, so we'll multiply this side, then divide by that, and so then X will equal 0.3922817. All right, sig figs would say 2 here, 3 there, 4 here. So our answer can only have 2. So we're going to keep the largest two place values, which is the tenths and the hundredths. All right, the 2 doesn't do anything to the 9, so X would be equal to 0.39. We found N, which is moles, so that would be moles. So that bottle at 4.7 liters would have 0.39 moles of gas in it. All right, and that is the ideal gas law. It is probably the most straightforward gas law, PV equals nRT. Doesn't require a lot of thinking. Sometimes instead of giving you N, it will give you grams. And if you have grams, all right, so if your N is, if it gives you grams, then you need to convert that to moles. And you do that by taking the grams and dividing by, so you're gonna divide by the molar mass, if you remember that from Stoic, and that's gonna come from the periodic table. All right, and that's it. Ideal gas law in a nutshell. Make sure you like this video. If you didn't understand something, watch it back. If you just want to give me some plays, watch that joint back again, share it with your people, tell your teacher about it, and make sure you hit that follow button. All right, Chemistry Coach Jakes, Ideal Gas Law. Y'all take care. Peace.